Standard 10th Mathematics Part 2 Chapter Trigonometry Solving practice set problems in video number 15. So children, with chapter Trigonometry, looking into practice set problems, the two problems written on the board say that prove that cot theta plus tan theta, the left hand side, should be shown equal to cosec theta into sec theta, and the second 1 upon sec theta minus tan theta, the left hand side, should be equal to sec theta plus tan theta. These are the two problems that we have to prove that the left hand side is equal to your right hand side. So let's begin with the first one. Cot theta plus tan theta we have to prove is equal to cosec theta into sec theta. Let's recall, cot theta plus tan theta stands as your left hand side. Cosec theta into sec theta is your expression towards the right hand side in this problem. We have to prove that the left hand side is equal to the right hand side. So let's begin, children. Let's start with our left hand side. So let's pen it down first. It goes as cot theta plus tan theta. Let's use proper mathematical basic equations or functions or trigonometric identities so that we reach to a step where in that simplified step we can say that the left hand side is equal to the right hand side. Now if we recall, children, we have seen that wherever you have such inverse functions like sec, cosec, cot, tan, it is advisable to change it into the basic functions like sine and cos. So what is cot theta? Cot theta is cosec theta upon sine theta plus what is tan theta? Let's substitute. Tan theta is sine theta upon cos theta. Let's pen down the reason that as cot theta is cos theta upon sine theta and tan theta is equal to sine theta upon cos theta. Let's move on with our steps, mathematical steps. Let's look at the denominators. You have sine theta, cos theta. Let's bring them under a common denominator. Sine theta, cos theta will be written as the LCM. Let's equate both the denominators equal to the LCM, that is the denominator sine theta, cos theta. So the first one we will have to multiply it with cos theta. Whatever we multiply in the denominator for the first term should be also applicable for the numerator. So multiply the numerator also by cos theta. So cos theta into cos theta is cos square theta plus the second denominator for the second term is cos theta. Let's equate it to the common denominator. So we'll have to multiply it with sine theta. So same is applicable for the numerator of that term to be multiplied by sine theta. So sine theta into sine theta is sine square theta. Now children, cos square theta plus sine square theta, can it be substituted by any numerical number? Can we use any trigonometric identity? Definitely. We know that sine square theta plus cos square theta or cos square theta plus sin square theta is equal to 1. 1 upon sin theta cos theta. Let's write down the reason. How did we replace it with 1? By using the trigonometry identity, that sin square theta plus cos square theta is equal to 1. Now children, we know the basic mathematical step. 1 upon a into b can be written as 1 upon a into 1 upon b. Same will be applicable over here. So 1 upon sin theta cos theta can be written separately as 1 upon sin theta multiplied by 1 upon cos theta. Right? So what is 1 upon sin theta, children? 1 upon sin theta, we know it is the inverse ratio of cosec theta. So let's substitute into 1 upon cos theta. Its inverse is sec theta. So let's write down the reason as 1 upon sin theta is cosec theta, 1 upon cos theta is sec theta. 1 upon cos theta is sec theta and 1 upon sin theta is equal to cosec theta. So this is the way we replace 1 upon sin theta as cosec theta and 1 upon cos theta as sec theta. Now let's move on further. What have we reached to? We have reached to a step where the left hand side answer gives us a simplified step as cosec theta into sec theta. Let's observe what is on the right hand side of the given problem. Is it tallying with the same expression? Yes, cosec theta into sec theta. So we can say this is equal to your right hand side. Thus it is proved that left hand side is equal to your right hand side. Therefore, cot theta plus tan theta is equal to your right hand side, that is cosec theta into sec theta. The reason will be as we have been able to prove it. So children, it is very easy to prove your left hand side equal to your right hand side in any given problem. What did we do over here? Whichever were your inverse functions, as far as possible, try to convert them into your basic and then apply mathematical steps to prove left hand side is equal to the right hand side. Now let's begin with the second problem, which again says prove your left hand side is equal to your right hand side. I will first write down the problem. Second problem, 1 upon sec theta minus tan theta you have to show is equal to sec theta plus tan theta. Now again children, over here what do we have? We have 1 upon sec theta minus tan theta you have to show is equal to sec theta plus tan theta. Again, the expression 1 upon sec theta minus tan theta is the expression on your left hand side. The expression sec theta plus tan theta is the expression on your right hand side. Let's begin with the left hand side. So let's pen it down. 1 upon sec theta minus tan theta. Now, if we recall children, the expression in the denominator, right, it will be advisable as it is a binomial. First step to simplify and move on with the calculations, multiply this binomial with its conjugate. Now we have already seen what is a conjugate, children. If the expression is a minus b, the conjugate will be a plus b. If the expression is a plus b, if the binomial is a plus b, what will be its conjugate? A minus b. So let's apply it over here. Let's multiply, observing the denominator with its conjugate. So if the binomial over here is sec theta minus tan theta, let's multiply it with its conjugate, that is sec theta plus tan theta. Let's not forget, whatever we do in the denominator, same is applicable for us to complete it and perform the same operation with the same expression in the numerator. So multiply the numerator also by the same expression. Let's move on further. Let's concentrate on the denominator first. Does this resemble any formula? Definitely, children. Sec theta can be termed as A. Tan theta can be termed as B. So, what does this resemble? A minus B into A plus B. A minus B into A plus B gives us A squared minus B squared. So, in the denominator you get sec squared theta, that is A squared, minus B squared will be your tan squared theta. Let's concentrate on the numerator. We'll have to open the bracket. 1 into sec theta is sec theta, plus 1 into tan theta is tan of theta. So children, what about the denominator? Do we have any trigonometrical identity where we can substitute and replace this expression by? So definitely, children, what do we have? We have 1 plus tan squared theta is equal to sec squared theta. But over here, what are we wanting to have? We want sec squared theta minus tan squared theta. So this term, let's transfer it in your right hand side. So we are left with 1, which is equal to sec squared theta minus tan squared theta. So children, sec squared theta minus tan squared theta can be replaced by using the trigonometrical identity and by writing the number 1. So numerator as it is upon 1. How did we replace sec squared theta minus tan squared theta by 1? By using the trigonometric identity which says 1 plus tan squared theta is equal to sec squared theta. So here we are left with only sec theta plus tan theta. Let's observe what is required on the right hand side. Is it tallying with the right hand side of the given problem? Definitely sec theta plus tan theta. So this is equal to your right hand side. So children, therefore, we were able to prove, starting with the left hand side, by simplifying it, to show our left hand side is ultimately equal to our right hand side. Thus, Thus, 1 upon sec theta minus tan theta is equal to sec theta plus tan of theta. The reason will be we have proved. So children, this is the way we were able to prove problems saying that prove that the left hand side is equal to the right hand side.